All right. This is 5.1 Anatomy of a Java Class. Have any of you guys taken anatomy? Do we have anatomy still? Yeah. Who teaches that now? Miss Avery. Okay. Right. That's anatomy of the human body. What's inside? Right. That's the easiest, simplest explanation of anatomy. What's inside? Human anatomy and physiology. This is the anatomy. What's inside of a Java class? We use classes, but what's really inside? Okay. Up until this point, I've always said, yeah, you learn the what, and you don't need to know the how or the why. Now we start learning the how and the why. You've chosen this class for a reason. We're going to start deep diving into these things and figuring things out, right? The abstraction that has gone into this, we've developed certain things that make things easier for you and told you, hey, don't worry about this for now. Don't worry about public static void main string args. Just use it. And I'll tell you why we use it later, right? That's how a lot of these computer science, I guess, topics work. You introduce it on a very basic level, and you say, hey, we'll dive into this more later on. Now's when we start diving into this. If you remember correctly, in Unit 2, when we were going through some of these things, and we're like, what is this? I was like, you don't have to know this now. In Unit 5, we'll do more of a deep dive into it. And that's what we're doing here. So it even has a callback in the very first sentence. It says, in Unit 2, we use classes and objects that are built into Java or written by other programmers, right? You can write classes. And from that, you can call objects. What class did we use very frequently in Unit 2? What class did we use? We got to move things around, change the color of things. The turtle class, right? The turtle class was written by someone, and we're able to use it. Okay. In this unit, you will learn to write your own classes and make your own objects from those classes. Okay. So the purpose of making these classes is really to save time. I love saving time. Okay. If there's anything I can do to save time and be more efficient, that's great. Sometimes we just write a program just so it works. But as we grow as programmers, we realize I just wrote that over and over and over again. Well, let me write that in a loop, right? That's less code. Well, what if you could even take it one step further and say, hey, I keep on doing all this work and I realize a lot of the code I'm writing is repeated. Can I simplify that? And that's where classes come in. It says, remember that a class in Java defines a blueprint for creating objects. When you have a blueprint for a house, right? Someone creates a blueprint. I know when I go to Texas, I see it all the time. I drive through a neighborhood and all the houses look exactly the same, right? In my mother-in-law's neighborhood, like all the houses, all on the inside are either the same exact setup or a mirror image of it, right? In your community, do you have houses nearby you that have like a very similar floor plan, right? The reason why they have that is so that if I'm a builder and I had to design a new house every single time someone wanted to build a house, obviously people get like certain things customized and changed, which is fine. But if I don't have a general blueprint to start with, meaning like a basic, a basis to start on, then I'm having to redesign every single time I write a program. What if I was able to write a class that for every single time I write new software, I could use that class, right? It would save me so much time. What if every single time let's say I'm a builder and I'm an architect and I design all these plans to build this. Let's say I want to build a new school. I develop all these plans and I package it all together and send it to the customer and they buy the plans and they end up building it, right? I could go to somewhere else in a whole different state and be like, hey, look, I designed these. What do you think? Like, oh, I saved so much time. I didn't have to redesign everything. Well, actually, like this one building, I want to make sure I add 2 more bathrooms and a couple other things. Oh, that's easy. I can go in there and do that, right? Well, what if I was able to design software that then I can ship out to other people if I'm already able to package all that up and save time? Think about the weekly learning plans that I have. The reason why I create weekly learning plans is so that I can use them year after year after year, and not every Monday sit down and be like, what am I doing this week? Guess what? Some teachers do that. Every Sunday night, what am I doing this week? Right? What's going on? And you forget what you did the previous year, and you forget what you did the year before that. And it's like, what are you doing? You realize there's patterns. I like recognizing patterns. I'm like, why am I so busy this week? Oh yeah, every year, this time of year gets super busy. I'll make myself a note. This week was really busy during week 7. Oh, 3 years in a row, week 7 was busy. I'm looking at this being like, hey, I got a busy week coming up. So documenting this stuff is important. That's why we create these classes, so that we can use them as a blueprint and create additional things come the future. If I want to teach a new class next year in the school, I would go to my weekly learning plans, and instead of adding a whole new tab, I would duplicate one that I already used, and then I have a template that I could fill in. Why would I spend all the time redesigning everything, right? Now, with that, obviously there are fields where it's nice to redesign things from an artistic perspective to just an authentic perspective. But if I don't have to, then I'm not going to. So with that, it's good to have a standard where classes are really good for being reused. It says when you create objects, you create new instances of that class. What you can do with those instances is determined by what methods are defined in the class. So anytime you create an object, right, that's just, we created Myrtle, we created Yertle, and it says it right here below, so I'll read it. For example, in Unit 2, we created Yertle and Myrtle. They were 2 turtle variables, 2 objects from the turtle class. We named one Yertle and we named one Myrtle. And assigned them references to objects created from the class turtle. And we use instances of Java's string class to assign values to different string variables. So we're able to pass in values. We told Myrtle, turn right. We told it to go forward. But what made it go forward? Didn't magically move forward. Someone behind the scenes had to write code and say, hey, every single time someone calls Myrtle, it's an object from the turtle class, but what do I want it to do? Move forward. What does that mean? It looks inside the turtle class and finds a method that's defined inside of the turtle class. Who defines it? The programmer. Okay, we didn't know what was inside. We didn't look what was inside, but if you're curious, now's where we look what's inside, the anatomy of what's inside the class. Okay, it says watch this short video to review the vocabulary of object-oriented programming. Now, we watched this in 2.1. You don't have to watch it, right?
Instance variables.
Basically, what it's saying is every single time you have a class, you can create objects or instances of that class. Okay. Most classes you write will have a keyword public before it. You ever think public, static, void, main, string, args? What does public stand for? Some of you might know, but most of you might have no idea. Well, let's talk about it. We're creating public, static, void, main, string, args. What does public mean? Well, it's a keyword. The class definition itself always starts with the word class, followed by the name of the class. Okay? The rest of the class, called the body, is defined inside of these curly braces. Now, we've been doing this, right? Any single code example that we have, even like the mix and match, right? I'll say, all right, we're looking at public class something. And I think someone raised their hand and said, what does public mean? I'll talk to you later about that. You don't need to know yet. Well, now we're going to talk about what it means. Okay? It says, since we're talking about anatomy, let's create a class called person. Capital P. Classes are almost always named with capitalized names, though this is a matter of style, not a rule. It's just a good standard. Yesterday, I was on a long drive. I was talking with this guy that does a lot of scientific research, and I was talking with him for hours. And we were talking about standards, the use of standards. We were talking about how USB-C is becoming a very popular standard now. And, now even, I can charge my phone with the same USB-C charger that I charge my computer with. Where a lot of Apple products in the past use the Lightning charger, right? Having standards is good, so that way they can be reused throughout. So a standard in here, there's a ton of standards in technology, but a standard that's typically used in this programming language for people as they're reading code, it helps to capitalize any class that you're working with, the name of the class. In this case, the class is named person. Okay, it says here's the basic skeleton of a person class. So we started with public. We define that we're starting a class, and we name this class person. And then you can write anything inside of these curly braces, right? And we can use it for later. Now, it says you can create instances of the person class with new. We did this with turtle, right? We would write like turtle Myrtle is assigned new turtle, right? Remember that? Well, we can say person Ada is assigned a new person. Person Charles, that was my grandfather's name. And that's actually my son's middle name. Person Charles is assigned new person. So what makes up the body of the class? What's the stuff between the two curly braces, right? What is this? Okay. So it says, remember the objects have both attributes and behaviors. Attributes can also be called properties. Attributes in like turtle were like the color, set color. You could change the direction that it's facing. So those are all properties or attributes. And the behaviors were actual methods that you would use to make things happen. Okay. These correspond to instance variables and methods in the class definition. Well, what are these? There's a reason why they're in blue. That usually means we're about to talk about them. The first things we define in a class are usually the instance variables, meaning inside this class, these are variables that we're going to use throughout this class. And for this instance of the turtle, for this instance of the person, we're going to use this variable. And this is what's usually passed in as a parameter. Okay. It says they are called that because each instance of the class, each object has its own set of variables that aren't shared with other instances. That's the reason why that we could do something to Myrtle and it wouldn't change something with turtle. If I were to say change Myrtle's line color to red, it wouldn't change Yertle's line color to red. They're separate, right? So they're all under the turtle class, but then I have Myrtle and I have Yertle. This turtle might look different from this turtle. It might be faster than this turtle over here, right? It has different properties, different attributes. I can look around this room and identify each of you by name. That's a property, right? I could identify you by the way you look, right? If you all looked exactly the same to the T, had the same backpack, same computer, same glasses, you wear exactly the same hair color, everything, I wouldn't be able to tell you apart, right? God designed us as unique beings. So, if he had a person class, right, he would then, for each person, be able to design them each uniquely. We are all uniquely and wonderfully made. So with that, as we look through this, recognize that we all have different properties in the same way that each instance has different properties. Okay, this is what allowed Yertle and Myrtle from Unit 2 to be at different positions at the same time. They each had their own X and Y positions. These were instance variables. The next thing we define in class is usually its constructors. I remember when I was in college and my professor did an awful job of explaining what a constructor was. I had no idea what it was for like a year. I was like, what's a constructor? I could have probably like watched YouTube videos, but back then even it was hard to find something that was just reliable. But I just couldn't wrap my head around some of these concepts, especially when it came to constructors. But don't worry, we're going to explain it a lot more clear now that I know I struggled through it, so that way I'd learn it and be like, all right, why didn't they teach it like this? Okay. Some people that don't know what they're doing and they're teaching computer science, they'll breeze through this and go through it really fast and then assume you're going to know everything. And then these next few chapters are then going to hit you really hard. So that's why I'm going through slowly. It says, we'll talk about writing constructors in more detail in the next section, but a constructor's job is to initialize the instance variables when the object is created. I used to think, what does that mean? Well, it says we're going to talk about it in more detail in the next section. Usually, that will mean that they will need to take arguments. So, the call to the new person before is to a constructor that doesn't take any arguments. In a moment, we'll see that person constructor, and we'll actually need arguments. It'll give us an example below here in a second. Okay, the real meat of the class is in the methods, which define the behaviors of the objects of that class. It says, recall from Unit 2 that most methods either do things or return values. So when it says do things, it says like the turtle methods that move the turtle on the screen. What were some of the turtle methods we used? Okay, forward. Myrtle.forward. What? Turn left. Turn right. There's this turn, right? Pen up, pen down. Set color. Go to, right? These are all ones that we used. Okay? With that, these are all called methods. And someone had to write these methods behind the scenes and tell the computer what to do. What made that little turtle show up on the screen, right? There was code written to make that happen. Okay? It says the methods of the class share access. Well, I guess above it says return values like get the X position, get the Y position. The methods of the class share access to the object's instance variables. And when a method is called on an object, it uses instance variables for that object, right? Which means that things can change. Instance variables could define what color Myrtle is, what color Yertle is, what position it's in. It says, for example, in the turtle class, the forward method changes an instance variable X position. Okay. Forward, I think, moved it forward automatically 100 if you didn't enter an argument, right? So somewhere behind the scenes, someone wrote that default in there. Like, hey, if someone doesn't pass an argument into here, it's just a default of 100. Okay. It says when you call forward on Yertle, it changes X position on Yertle object. And when you call Myrtle, it changes the X position of the Myrtle object. It doesn't affect the other one. Okay. If you take 5 steps that way, that doesn't mean that I have to take 5 steps that way. Okay. We all think differently. Putting it all together, the 3 main anatomical features of a class are the instance variables, the constructors, and the methods. So the instance variables hold values associated with each object. It's basically like a little like mini like bio, right? So think of the instance variables like a bio. I run a few soccer teams. The Salisbury Stakes had their first game this weekend, right? You can go through each player, their height, their weight. So it's just a list of the object's properties. It's just a list of the object's properties, right? Those are the instance variables, right? and your instance variables are different from someone else's instance variables. But that's what defines someone in the person class. The constructor, it says the constructor's job is to initialize the instance variables, basically just make them happen, right? We initialize them. And then we have methods, right? That's usually the meat of it, a lot of methods. It says contains the code that gives the objects their behavior and which can use the instance variables defined in the class. All right. So we're talking about all these things. It'll be a lot nicer when we come down here and look at things in person, right? Okay. It says, finally, one last bit of weird anatomy, kind of like an appendix. Any Java class can have a main method, which can be used to run that program, run that class as a program, either to test that one class or sometimes as an entry point to the whole program, right? The main method, public static void main string args, is where the computer looks at first. They look for the main method, okay? Designing a class, okay? We talked about the anatomy of the class. What about designing the class? Well, we have some things below, okay? It says, now that we know what the skeleton of the class looks like and the elements that make up the body of the class, we're ready to create our own class, finally. Listen to me talk for a while about this. Now we start to make our own. Let's start with a quick look on how to design a class, such as person, right? One important question we have to ask when designing a class is, what data does it represent? What does that mean? In this case, we ask, what would we want to know about a person, right? You meet someone for the first time. I just got back from Mexico. I met a lot of people. First thing, introduce yourself. What's your name, right? One of the things that was important to me was, hey, like, do you speak English? What language do you speak? How can we communicate, right? What federation are you from? Are you from Mexican Federation? Are you from the Moroccan Federation? Are you from the Australian Federation? A lot of times you can just tell by their jacket where they're from, but those are properties of that person or instance variables. So it says in this case, what do we want to know about a person? Our answer will depend on what problem we're trying to solve. I love solving problems. I love a good problem that takes a bit of time. It's important to be able to want to solve problems as a programmer. The whole purpose of being a programmer is wanting to solve problems. A software developer is creating solutions where there are problems. Okay. In one program, perhaps an address book, we might want to know the person's name, phone number, and email. When I took over as the head coach of the futsal national team, I wanted to develop a database of all the top players in the United States, right? What would be useful information? Their first name, their last name, if they have a valid U.S. passport, if they're a U.S. citizen, their position, right? Their date of birth, their email address, their phone number. I can make a little Excel or Google sheet just listing all that and go through and create it. Height, weight, what team they currently play for, who their coach's information, right? If you want to go to college and play a college sport, right? Or even if you just want to apply to a university, what's important information that the university is going to ask for from you, right? They're going to ask you what school you went to. They're going to ask you what your GPA was, what your SAT, ACT is. They're going to ask you for letters of recommendation. These are all things that we want to collect. But if I'm just assuming that we need things, it might be just information we don't need. So it says, okay, in one program, perhaps an address book, we might want to know the person's name, phone number, and email. Okay. In another program, such as a medical application, we might need to know their vital signs like blood pressure, their temperature, and pulse rate. Those are things that are very valuable. Okay. For now, let's go with the address book example. And here's a fleshed out person class with instant variables, a constructor, and methods down below here. We'll go through the details in the next few sections, but for now, you can run the code to see how it constructs two person objects and fills in their data. We'll run that in a second. It says, remember that execution always starts in the main method. So when a method like print is called, the code defined in the method runs, but when it gets the values of name, email, and phone number, it gets specific values of those variables that were set by the constructor when the particular object we're called print on was created. So we look at this. First, I have a class. It says person. My instance variables. Remember, instance variables, constructor, and then all my methods. Okay, so my instance variables, I have a private keyword. Talk about that later. A private string name, a private string email, and a private string phone number. These are all variables that will be used. Now, your name is different from your name. Your phone number is different from your phone number. Your email is different from your email. Okay? So each of you have uniquely identifying, things. And if you guys ever learn about database design, you learn maybe how to write SQL or other programming, back-end languages. You will learn that every record needs a unique identifier. In the United States, a common unique identifier for every human that lives in the United States, a common one is their social security number. You're assigned a number. This is your number assigned by the government to make you unique. So that way, if there's another Gregory Maryland, Greg, what's your middle name? Alexander. If there's another Gregory Alexander Maryland, that you don't get confused. You have a unique ID number, and that's usually your social security number. In APCSA, when I was in school, we had an ID number. Do you guys still have ID numbers? Right? 8164 was my ID number. And I used to look on the wall, and the teacher would post all the grades on the wall by your ID number. And that was unique to me. Right? You end up finding out who was the worst student in the class because you end up finding out their ID number and was like, oh, like that person's failing. Oh, that person has 100% in every single class. Right? But it's unique. Sometimes some of this information is personal. Right? If I were to ask you for your social security number on a live stream, don't tell me. Right? But that is something that is unique and that is identifiable specifically to you. Thus, why it is private, right? You don't need to know this. You don't need to share this with other people. Someone asks for your phone number, you don't have to give it to them. It's private, but you can make it public if you want. But it's good to start off with it being private. Someone asks my kid, hey, what's your address? They know not to tell them their address, right? I also think it's important to have a separation where, students shouldn't know my phone number, right? That'd be dumb. You have my email address, that's public. I'm not going to give you other private things. Okay. A constructor. It says a constructor constructs a person copying the data into the instance variables. All right. So we talked about a constructor. I remember in college, I was like, what in the world is a constructor? I don't get it. Why is the constructor named the same exact thing as the class? Right? Public person. Okay? What you do is you make it public. You write the name of the class. And then you're then initializing every single one of those instance variables. So this is when you tell the turtle, right? You're creating a new turtle named Myrtle, or you're changing something within it. You can change these instance variables in here using this. And sometimes you realize we were putting inside, we did turtle, and then inside parentheses, we would put world. Remember that? We would pass that argument into there, which would then accept that in the constructor and then change the value of the instance variable.
So basically, the constructors literally just build the instance variables. They exists in a digital way.
Correct. So we like declared the variables up here, but then the constructor initializes all those variables, right?
It'd be like God saying, "Let there be light," and then a constructor lets there be light. But like it's God. God is the constructor as well.
Okay.
Kind of.
Yeah. Because I've tried to wrap my mind around that. Sounded good in your head. Yeah, Greg.
Why initialize them initially and then later on, like add attributes to it? Why not have it in a way where you initialize and also set out the same?
I mean, you could do that, but what name would I start someone with? Right? What email would I start someone with? me@me.com. Right? What phone number? 555-555-5555. I guess you could, but you don't need to. That's extra code. Why would I type more than I have to? I'm lazy. Right? All right? Best programmers are lazy programmers. You don't have to initialize it, then don't. Because we're about to initialize it right here in the constructor. Okay? Okay, and then we have our methods. Right here, we just have one method. It says public void. What does void mean? We haven't talked about void. Public void print. We'll talk about void in a minute. So we print out system.out.println. We print out name and then whatever was constructed and passed into it. So that is a person.print, right? Calling person.print would go through and do all this for me. Okay, take the email that's assigned. So let's just go ahead. So look, remember the program starts in the main method. So the computer looks for the main method, finds it. It doesn't look at any of this stuff yet. Okay, it looks for the main method. And it says, all right, public static void main string args, cool, that's where I start. There's a comment here that says call the constructor. Okay, person P1 equals new person. Remember when we did turtle myrtle equals new turtle, and then we passed it in world, right? Well, what if we passed it in Santa? That's a Sana? I don't know. Sanya?
I thought it was
Sana. I don't know. Maybe it is, right? sana@gmail.com. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay? So we pass that in. The constructor then receives it. And when the constructor receives it, it takes, check this out. It takes it as a variable called init name. You can name it whatever you wanted. And you assign it to name. And then it takes the email, whatever the email was typed in, it assigns it as the parameter init email. And then it reconciles it with this instance variable up here. Same with init, which is like initialize the phone number. It doesn't have to say this. It could just be like N, E, and P, right? That would have worked, but it's a little vague. I'd probably do that because I'm a bit lazier, right? But I would say like N, E, and P, name equals N, email is assigned E, and phone number is assigned P. But they went in and added this in there like that. You can do it that way. Okay, so that's what this line of code did. And then once I have this P1, check this out. I said P1.print. Remember like Myrtle.moveForward? Well, the computer sees P1. Oh yeah, P1 was in the person class. It was an instance of it. Let's look what's in the person class. Is there a print in here? There is a print in here. What does print do? Oh, it prints out this, this, and this. I'm going to do that. And the semicolon makes it happen. Person 2. We can create a second person, right? Imagine this is God just assigning people like, hey, I'm going to do this, add this, add this, add this. Boom. From the class, the blueprint that's created to create a person. Right? We're all different. P2 dot print. Let's run all this and see what happens. Name, Sana. Email, sana@gmail.com. Phone number, 123-456-7890. Name, Jean or Jean or Jean. Jean@gmail.com. Phone number, 4404-899-9955. Think it's a real phone number?
It doesn't exist.
Doesn't.
404 doesn't exist.
404 doesn't exist? Man.
Well, I mean, obviously, it's like a play on the error number. 404, site not found.
Try it.
I don't know. All right, hold on. Let's call it. 404.
The first one was
Yeah, the first one won't work.
The second one was also kind of supposed to be that way.
All right, hold on. Number not valid. There you go. I tried. All right, 513, instance variables. Okay, we saw how that worked. We stepped through it pretty slowly. As we've said, instance variables hold the data for an object. They record what an object needs to know to play its role in the program. Okay, instance variables can vary based on the actual instance that's being used. Instance variables are also sometimes called attributes, fields, or properties, depending on the programming language, right? Properties is common, attributes are common. In general, and definitely on the APCSA exam, instance variables should be declared private. I'll repeat that. On the APCSA exam, instance variables should be declared private. So let's look back up here, right? When we declare these instance variables, they're private.
Is that so people can't like see them when the program runs? It like lists out all of the things.
Well, it allows you also to reuse that variable name, and that these are only private to this class. So it's not getting confused later on. A different, like you might have a different class and you don't want to think of a new variable name because name is important. So private, it's being used inside of here. It could be for security reasons, but really the main reason is, well, one of the biggest reasons is so you can reuse the same variable name in different classes as well. It says, think of private as like your diary. Only you should have direct access to it. Similarly, in Java, a private instance variable can only be accessed by code in the class that declares the variable. So like outside of that class, if you're trying to access something, if you're trying to access the social security number in there, you shouldn't have access to it, right? If you use the private. It's good just naturally to make your instance variables private, just for a rule of thumb, but then we can eventually expand on that and talk about more later. It says instance variables are declared right after the class declaration. They're the very first thing we define. They usually start with private and then type the variable and then a name for the variable. Private means only the code in this class has access to it. Okay. It says the person class declares 3 private instance variables: name, email, and phone number. These are things you might want to know about a person, right? Let's say I'm creating my database of all the top futsal players in the United States. They are declared at the top of the class, and they exist inside of the curly braces of the class. Once we've created a class like person, we can create many instances of the class, right? The class is like a blueprint or cookie cutter. I know this is a good time of the year to make Christmas cookies. You guys like making Christmas cookies? My wife has like this box of cookie cutters. It's like this big, right? It has all these different cookie shapes, right? And then the kids like making gingerbread men or we have like dinosaurs, dogs, Christmas wreaths, things like that. And then we just have plain ones too that are just like circles or like triangles. Okay, but those are cookie cutters. The reason why cookie cutters are made is so that you can just boom, stamp, 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 stamp. My wife just got a stamp with our return address. She's sent out Christmas cards. Your parents ever sent out Christmas cards, right, to people? Can you imagine writing the address, your name, your address, return address over and over and over again? It gets annoying, right? You just have a stamp. Boom, 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 right? It's easier, right? It saves time. It might be more authentic to write a note by hand, right? It means a lot more. A quick way to get me to cry is to write me a very like heartfelt note. Like, I don't know, there's something about authenticity is just like whenever my wife will like paint me something or like write me a note, a really long note, right? And that is more emotional and that hits home more than just like, I don't know, just like a typical greeting card, right? But this one I picked up is from Josh, right? I won't read it to embarrass you, right? But I like keeping personal notes, right? I like authenticity, right? I have a big box at home. It might have some in here too. A big box of all these notes that people have written me over the years between students I've had or family members. And I like looking back at them every once in a while and reading through them. I don't know. I like that. I like the heartfelt and maybe artistic side of it. And sometimes it makes sense to not use a cookie cutter. Sometimes it makes sense to be artistic with it and do your own thing. But sometimes you need to just save time. Right? So with that, you have recipes. Sometimes you follow a recipe to the T. Sometimes you just say, hey, like whenever I make chicken tacos, I don't know if you could tell me how much of the adobo seasoning you put in, how much cumin do you put in, how much chili powder. I don't know. That looks right? And make it. It's not the same amount every time. I'll measure it out, right? I do have recipes that you need to be measured out very specifically. But with this, these are specific and, we think of each class like that blueprint or cookie cutter. It defines the variables and methods for the class, but doesn't give you all the specifics. The specifics can be later changed. Okay. Each object will have their own copies of the same instance variables, but with different potential values, as seen in the cookie decorations below. Right? So, you have this cookie cutter. Okay. It's perfect. I'm going to show my kids this when I get home. We should make cookies tonight. Right? It says the person class, you have this cookie cutter, okay, has a name, email, and phone number, but we haven't actually decorated it yet. The methods that we can use are passed in. Look at that. They got lazy like me. String N for name, string E for email, and P for phone number, right? That's what I would have done. They decided I'm not going to use init phone or init email or init name. It's too much typing. N for name, E for email, P for phone number. Unless you have like, I don't know, another one that could be mixed up in there, right? I don't know. So it's like, hey, look, this is just a list, right? We're creating this person, but now we can be specific, right? We can assign name, email, phone number. In this case, right, this picture over here, we didn't assign name, email, and phone number, but they both have 2 eyes, okay? They both have 2 arms, 2 legs, right? You could take a bite off that gingerbread's leg and it have 1 leg. Would it still be a gingerbread man?
Yes.
No? Yes, it would still be a gingerbread man, right? But it would just be missing a leg. Maybe the property is missing leg equals true, right? It's a Boolean value, right? So with that, this gingerbread man's not wearing any clothes. He's wearing buttons but no clothes. Or maybe these are just like, I don't know, right? She's wearing clothes. He's not. right? She's wearing a pink dress, I guess. I don't know. Whatever gingerbread people wear. She has a heart on it. This guy has buttons. He has green eyes. She has white, like whatever the dimples are called, right? What's that? Eyes are the same color as the guy.
White and the red outside.
I see. Right? Different instances from the class. Okay, so good Java style stresses data encapsulation. Okay, key word. This is one of the key components of Java is encapsulation. Okay, what is a capsule? Yeah, okay. If I give you ever read like medicine? It's like take 2 capsules.
It's like a
Right.
closed container.
Right? When you take a capsule, like a closed, like a, I don't know, like ibuprofen or something, right? And you take that, what happens to that capsule? Hopefully, right? Hopefully it dissolves, right? Hopefully that capsule dissolves. You put it in your mouth and you don't chew it up. You swallow it, hopefully. I remember for a long time it was hard for me to swallow pills, right? My mom like dissolved it and I had to chew it. It was just gross. Then you got used to it. Then you guys take pills without like water? I can't do that. I have to drink water when I take a pill or some sort of liquid. I can't just put it in my mouth and swallow. I don't know how people do that. You guys are anomalies. Okay. But a capsule, it contains something, right? What's inside of that capsule? Right? Could be something good, could be something not so good. What's inside of that capsule? Well, you take something and you package it up. Okay. That's considered encapsulation, the process of putting something inside a capsule, right? So data encapsulation. It says where the data, instance variables, and the code acting on the data, the methods, are wrapped together into a single unit and the implementation details are hidden, right? Because only the code in the class can access or change the values of the private instance variables. In the same way that like we didn't know what was inside of the turtle class, I just told you, I was like, hey, look, use this method. Why? Don't worry about it. Well, what's inside? Wait, like, how do I do that? Don't worry about it. Just use it, right? You learned the what and you learned how to use it, but you didn't necessarily learn why or like what's inside. Right? Some people like a lot of people get interested in like cars and they want to learn how to fix cars. You know, one of the first things they do? They break it. Why they break it? They want to figure out what's wrong, right? If you don't deal with a broken car, you just learn, hey, when this happens, do it. If you never actually fix it, that's a problem. So some of you guys that are afraid to run your code and get errors, it's great to run your code and get errors because then you're like, what do I do to fix it? Break your code on purpose at times. That'll help you, right? So it says, because only code in the class can access or change the values of private instance variables, it is a lot easier to keep track of how your program works than if you had to worry that any code anywhere in a much larger program could possibly change the values of the variables. Okay? Code in other classes can interact with the public methods, right? So Myrtle and Yertle could each use the same methods, but they couldn't access, unless it's specifically called, they couldn't just dive in and be like, hey, like, what does this look like? Right? That's like hacking, right? You cannot directly access the private instance variables shown in the pink box above, right? Couldn't access that unless someone tells you. If someone says, what's your name? You don't tell them. They can guess or ask someone else that might know your name, but that's up to you to decide whether you tell that person your name. When designing a class, you get to decide what data to make accessible or modifiable, changeable. from other classes and what public methods you provide. You get to decide. You're the creator, right? You're an artist in this. Remember from Unit 2 how turtle class provided get X position and get Y position to get the turtle's position, and no set X position and set Y position, right? Since the only way to move a turtle is through forward and move to. So the reason why we had Unit 2 was so that we could use it first and then take a step back and be like, all right, this is why we did this. In the same way in math, right? Sometimes when you're learning Algebra 1, geometry, Algebra 2, you're learning these things and you're like, why am I learning how to do this? Right? This makes no sense. And then towards the end of Algebra 2 in the pre-calc, they start piecing it all together. That's why I learned the quadratic formula. That's why I learned how to do proofs. And they piece it all together and you get the calculus and you're solving problems. Right? So you learn some of the steps and bits and pieces, and then we start bringing it together and we learn why. This is where we're at right now. Okay. It says click on the instance variable declaration in the declarations in the following class. Okay. So the declarations are there and there, right? That's where we declared it. Usually it's the top. Public name. What is this right here? This is the what? Starts with a C. The constructor. Okay. It uses, the way I know is it has the same name as the class. So if someone on the outside used the name class, they're going to pass in two values. They're going to pass in an argument that then is received as a parameter called the first and then the last. And then those are assigned first and last. Those are your constructor. Okay. Then I have a method called set first. If I want to set the first name and change it later, right, I can use a setter. If I want to change it later, I can use a setter to set last. Check me. Correct. Okay. Now to methods which define what we can actually do with an object. The most important methods in a class are the public methods, since they can be accessed from outside the class. You may also write private methods that are not accessible outside and therefore can only be used by other methods inside that same class. All right, so if you write a method and it's private, it can only be used inside of that class. Why would you want to do that? We'll talk about that later. As you've probably figured out, the public and private keywords determine the external access and visibility of classes, instance variables, constructors, and methods. Okay. Methods define what the object can do. They typically start with public, then a type, then the name of the method followed by parentheses for optional parameters. So we're going to talk about methods here more in depth. Methods defined for an object can access and use its instance variables. Okay. The person class above how far above? Person class above has a print method that prints out all the data stored for a person object. So the person class was right here. The print method that we defined, right? We defined this. Remember how I said public void? What does void mean? And I said, we'll talk about that later. Here we go. So notice that it's marked as public, and after public comes the return type. The void, return type. Okay, void. What does the word void mean in context of outside of computer science? You hear the word void, what do you think of? What's that? Okay, so nothing.
I think like a hole, a black hole.
A black hole.
A large empty space.
Empty space, large empty space. Okay, so public void. The return type, as you may recall from Unit 2, I don't recall talking about it in Unit 2, so I probably bet most of you guys don't remember talking about it in Unit 2. Unit 2 seems so long ago. It's used to indicate that the method does not return anything, but has some effect, such as printing to the screen. So like nothing directly is returned from it, but it does call a method in this case. Okay. So after the return type comes the method name followed by parentheses containing the list of parameters. In this case, there are no parameters, but we still need the parentheses. The body of the method is in the curly braces. As we discussed, the method can access and use the instance variables defined in the class: name, email, phone number. Okay, so here's what we had. Public void. When we run that print, so person.print, it doesn't return anything, but it does something, right? It doesn't give you anything, but it does something. And that might be kind of unclear, but I'll explain it. Yes.
If it were to return something, would it be like in the context of a Boolean value
Or string.
or would it be something like something else?
Could
Like
be could be string, could be something like a different type. Let's see if we have
so like
one
the
down
void
here.
is just so far every program that we've had is void, so I'm guessing like it only matters like if it's not void if there are multiple different of these methods running in the same program, right?
Well, I guess it's what the method actually does. So we haven't discussed more, and we'll definitely dive further in that question. That might be confusing right now, but we're just introducing it. Trust that we'll dive deeper. Okay. It says to call a method, we need an object that is an instance of the class, such as we get by calling its constructor, right? Then we use the dot separator. Remember, we did this when we were saying Yertle dot forward, Myrtle dot change color, Yertle dot pen up. Okay, we use a dot separator to call its public methods. Okay, for example, p1 dot print, right? We created this new person and we called it p1 for, I'm guessing, person one. And then the arguments we passed in were sana at gmail.com, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's a phone number. Those are then passed in to that. And then I specifically called the print method. And by calling the print method, we found print inside of our class. We found out what it did, and it printed something out for us. So it says, click on all the lines of code that are part of a method in the following class. Okay, so this was our instance variables. This was our constructor, and all the lines of code that are a part of a method. Well, this is a method. And this is a method. Let's go ahead and see if that's right. You're correct. Instance variables, constructor, methods. Okay. Object-oriented design. Okay, we get to the object-oriented side of Java. What in the world does object-oriented mean? Well, we work with objects, right? That's what it means. So, so far we've just talked about designing a class, designing one class. In object-oriented programming or object-oriented design, programmers often start by deciding which classes are needed to solve a problem and then figure out the data and methods in each class. So like if I'm about to write a program, right, I think of the problem. Okay, why am I writing this? What's the problem? Okay, our school needs its own app. Okay, all right, so the problem is we need an app. What are some things that would need inside an AACS app? What's that?
Better access to, like, quicker access to the post.
Yeah, what if like inside the AACS app, I could send push notifications to people's phones Let them know, hey, school 2-hour delay. School's canceled. What if there was like a link to the website or like the school calendar? Maybe it's to solve a problem. Maybe people are like, I don't like receiving all these texts. I wish there was an app. I wish there was just one place for everything. Well, that's a website, right? But cool thing about an app is you download an app on someone's phone, you can then send them push notifications, right? Like, hey, by the way, check your email about an important announcement from the head of school, right? Now, some people don't want that, but some people want it. They're like, hey, send me those notifications. Maybe something happens and we're like, we need quicker access to parents in case something happens. Maybe an app would solve that problem. Okay. So what are things that need to be done inside that app? You start writing out things that you want inside of it, right? And then you start thinking what needs to be done and what has to fire in order to make things work. And there's the methods that you create. And you think about all these things first before you start programming them. And then once you've like storyboarded everything, designed the way you want things to look kind of in your head, and like made a rough estimate, then you can get started on it. Okay. So we want to decide which classes are needed to solve a problem, then figure out the data and methods in each class. When you're given a problem specification, you can identify classes you'll need by looking for the nouns in the specification. For instance, the specification for the turtle graphics system from Unit 2 probably contained a sentence that said something like, there are turtles that can exist in a two-dimensional world and can draw lines by moving around the world. The main nouns in that description are turtle and world. And indeed, the classes in the system are turtle and world. The one noun that was not turned into a class was line. Do you think it would have made sense to make a line class? I don't think so. Once you determine the classes you need, then you can go through the process we described above to design the classes, right? Instance variables, the constructor, and the methods we would need. Note that you can often identify methods that should exist on classes by looking for verbs like move, right? What do we want it to do? Sometimes it's useful when designing a complex system with lots of classes to make diagrams. Okay, I took a class in college called, it was IS 170, Systems Development with UML. And all we did, we had zero programming. All we did was like, they'd have a problem and say, all right, if you were to fix this problem, what would you do? And you had to use this unified modeling language, the standard used, looks like that below, right? Where you create these classes and you have to identify, before you write any code, identify what the attributes would look like, what the methods would be. And then eventually I would then program them. And this would like be my list of things to do, right? I like lists. So, hey, by creating a list and having this too, I could split this up into teams, be like, hey, this table, write this method, this table, write this method, this table, write this method. We combine all our code together, we put it all together. All right, package it all up. We have a class. It says you can make diagrams. Often these can just be sketches in your notebook or on a whiteboard, but there are more formal systems such as a unified modeling language, UML. There's a software that we use called Microsoft Visio. Have you ever heard of it? There's Microsoft Excel, Microsoft Word, Microsoft Publisher, Microsoft PowerPoint, and there's Microsoft Visio, right? And it comes sometimes in that package when you get like it. And you should check on your computer if you have Microsoft Visio, but that allows you to use and create these, like, I guess, in UML. For example, here's a UML class diagram. So if anyone ever says, if you're writing a resume, you're like, hey, have you ever used UML before? From the outside, you're like, what is UML, right? One of your friends, like, what's UML? It's just designing, like making things look nice before you program, right? That's it. It's kind of like in UML2. Remember how we made like flowcharts? And I told you like the diamond means that there's a change, right? Or like there's a decision being made. And that's part of UML. That's the standard. Here's a UML class diagram for the turtle class. The in front of attributes indicate that they are private, and the minus in front of, and the plus indicate that the methods are public, right? So the minus shows that they are private, and the plus means they're public. Here's a tutorial on class diagrams. We're going to skip over that. You can always go back and look at that if you're interested. It explains in more detail. These class diagrams are not on the APCSA exam. If you want to draw your own, these are some tools. Maybe you can play around with them later if you want. You've been hired by your school to create a program that keeps track of students at your school and the courses they are taking. Hopefully, you can find that out by Veracross. But let's say we didn't have a Veracross and we couldn't track that stuff. Name 2 classes that you would create in your program. Okay, so I want to create a program that keeps track of the students in the school and the courses they are taking. So maybe I could create a students class, right? And maybe I could create a courses class. I could give me like course descriptions that could give me all the class offerings, what the requirements are for people to sign up for that class. Okay. Name 2 attributes for each class. Okay, so maybe we could say attributes from students would be like, I don't know, like ID number or like year, like what year they are in school. I could have one attribute be like the name of course. Another one could be right. So maybe course difficulty. Would that make sense? I guess so. You could say prerequisites. You have an instance variable called prereqs, what you have to take before the class. If you haven't, like if you're a freshman, you try taking this class, that'd probably be difficult, right? You could maybe make one called description. Course description. Okay. The 2 nouns in the problem above are student and course and would make good class names. So maybe instead of students, name student. Just like we did the turtle class, it wasn't plural, of course. Then you think about what data to keep track of the students in the courses. Note the instance variables in the person class could also work for a student class. Say you wanted to make a computer game from a board game that you're playing. Think about what objects are in the game. For example, trademark Hasbro games. Example here, the description of Monopoly. Buy, sell, dream, and scheme your way to riches. Players buy, sell, and trade to win. Build houses and hotels on your properties and bankrupt your opponents to win it all. Chance and community chess cards can change everything. What classes would you need to create a computer version? What classes would you need to create a computer version of this game? Remember to look for nouns. So maybe we have like a what classes would you need? Maybe we could say have like a money class, maybe have like a houses class. Huh.
Players class.
What's that?
Players class.
Yeah, players class. I like that. Take one that you listed and try to come up with two pieces of data that use instance variables. So for the player, maybe I say two instance variables could be money, how much money they have. Another instance variable could be, I guess, board location, right? Okay, programming challenge, riddle class. In this project, you will create a class that tells riddles like the following. Riddle question: why did the chicken cross the playground to get to the other slide? First, brainstorm in pairs. We'll do it together. To create an object-oriented design for a riddle-asking program. What should we call this class? So I'll just call the class riddle. Well, then below it says, what data does it need to keep track of what data does it need to keep track of in instance variables? So I guess the question would be one. The answer would be another. What methods do we need? You could draw a class diagram for this, although it's not required. So what methods do we need? We probably need a method that prints the riddle. So we'll say print question. And maybe we have one called print answer. Maybe we have another one that maybe get no. I don't know, we'll play around with it later. We'll see what it actually asks of me. Write a riddle class in the active code template below that has two instance variables for the riddle's question and answer. A constructor that initializes the riddle, and two questions to ask the riddle and answer the riddle. Don't name your instance variables init question and init answer since they're used below. Okay. So it says write two instance variables for the riddle's question and answer. So I'll call this, so if we look above, right, I guess looking back at the example that we had here, right, notice that our instance variables, they're always what? Private. Okay. So we're going to make ours private as well. I'm going to say private string question. And then private string answer. Okay. It says set the instance variables to the init parameter details. Okay, so we'll say question is assigned init question, and answer is assigned init answer. This is my constructor, right? And then I have a method print question. So I would say system.out.println I'll Google good riddles. Oh, I got a good dad joke here. Okay, found one online. It says, which fish costs the most? I'm going to print out a goldfish. Huh. Okay. Now down here, it says call the riddle constructor to create two at the end of class. All right, guys. We'll finish this next time. This will take only like a few more minutes to finish, but I hope you guys have a good day. I'll see you on Wednesday.